Well, thank you very much, Gauhar, for the invitation to be part of this meeting here. More than anything else, it's an opportunity to meet friends and be away from a rather hectic schedule of my day. So taking a day off, coming to Delhi and being here is very pleasant. I have been kind of thinking what kind of points I want to make here, and I must say that I'm not an expert, I'm not a philosopher of science to talk about in defense of scientific method. I'm a practicing scientist, but also have been engaging with science pedagogy and science dissemination in a rather broad and big way for a long time. So therefore, I'm going to share my thoughts which have come to my mind while debating on these issues, while participating in programs. And it may turn out that there are kind of somewhat disjoint points that I want to make. I think it's good to first, in one's own way, state what one thinks is the scientific method before one moves on to defend it. And there might be gray areas in that also. See, I had given a talk some time ago which was titled Distinguishing Science from Technology and Spirituality. And I will come back to that because many times we try to distinguish science from religion and spirituality and different ways of finding truths. But we don't mind clubbing science with technology and calling it S&T. To me, the distinctions from both ends are equally important, and therefore scientific method may be used elsewhere also, but the whole endeavor of science has this connection on both sides, and therefore confusions on both sides, I think, exist. Very briefly, I would say that you build scientific hypotheses which are based on rationality. So the first pillar in my mind to scientific method is rationality. But as one knows that rationality or logical constructions have problems. I mean, first of all, things could be equally logical. And then what do you do about them? The second, of course, is a deeper problem which comes from Gödel's theorem that logical constructions cannot be complete. They are, by definition, incomplete. Therefore, science then, of course, uses empirical method of validation or finding examples from data and carrying out experiments. And that also we know then cannot be done because even for a computer program to be shown to work correctly, you have to test over infinitely large number of inputs. So that also stops somewhere. So then third pillar comes, which is the guild of scientists who at that time put a stamp and validate and say, this is all right, this is the best what is available today. So with these three pillars of rational or logical hypotheses coupled with empirical methods and experimentation, explorations, and finally a group of experts which validate at that time the best possible scenario, I think are three pillars of scientific method defined somewhat loosely and not very precisely as a working definition which I would like to put forward. Now what is it aimed at? Because as was mentioned by earlier speakers that science is exploration of truth, trying to find the truth about the world around us, or maybe a human understanding of the world. So in some sense, it connects with the language project also, that we are trying to give a certain language to the processes which are happening outside our mind in a way that they can be communicated, they can be documented, they can be used, and so on. So one can, I don't like to say that it's trying to find the absolute truth or whatever, but it is something to do with trying to find what the word is all about and truths of the word. And therefore, many times what happens is that you start saying that the goal of science is same as many other endeavors which also talk about finding the absolute truth of the world. But then the methodologies are very different, the method is very different, so therefore it is important to, I would say, distinguish science from other ways of trying to make sense of the world. Some of them might be very irrational and one may want to discard or not. Some of them might be just different from the scientific method and then one has to maybe see them as moving parallel and so on. We can come back to it in the discussion. The second distinction, as I mentioned, is equally important, is that in technology, when one is trying to modify objects around us for human use, it may be very useful to know how things work, and it might be useful to find the truth about them. But even if you don't know the truth about something and that thing works and you can show it empirically, it's a good technology. So the goal is use and not understanding. Of course, understanding can help you to use and so on. So they are interrelated, but I think these distinctions are also equally important. Well, so scientific method, as I mentioned, is a very broad way of doing things, and therefore it goes beyond natural sciences. In principle, it can be applied to various kinds of disciplines wherever one can make progress using this kind of a methodology. And some people would say that this takes you somewhere, but then one has to maybe go beyond that also. What I see is that even by the practitioners of public engagement of science, where people are talking about scientific temperament and scientific way of thinking and disseminating that to public, there are certain confusions which arise as I participate in programs I see. So one confusion is that if there is no rational explanation to a phenomenon, then maybe one should discard that phenomenon and say it doesn't exist. Now that, I think, one has to be very careful, because science keeps on progressing and moving, and there is a lot of stuff is unknown in the world around, and therefore there is a word of known and there is a word of unknown. And in the word of unknown, it's kind of anybody's guess what is going to happen. So to give you an example, we all have grown up thinking about Big Bang and expanding universe and so on, and I think till about 30-40 years ago, people thought that the problem is kind of solved and there are three possibilities that our universe can take. Either the density in the universe is very large and it is going to collapse back into the singularity from which came out. And then the second one is it's critical, it's going to expand and slow down to a zero motion state. And the third is that density is very low, the kinetic energy is very large, and therefore it's going to keep expanding forever and so on. But in all three, gravity is pulling it inwards, and since gravity is an attractive force, there is the expansion rate slows down, and that was considered gospel. But then, now if you ask someone, the universe is not just expanding outwards, it's accelerating outwards. Which means there is certain repulsive component to gravity, which nobody thought about. And that is a completely unknown domain. And even within physics parlance, we call it dark energy. Dark energy is just a name given to something about which we have no understanding. So what I mean to say is that trying to very rigidly interpret science and then treat it as a gospel truth sometimes lead to problems. Similarly, COVID vaccines. So there was a time when lots of people were talking about that it's completely unscientific if you are not taking a COVID vaccine. But then if you look at the whole parlance of COVID vaccines and the economics of it and the forces behind it, you realize that, the scientific method or the argument based on something being scientific might be a legitimacy that somebody wants to gain about what they are giving you in one way or the other. So this is true of many medicines which were pushed, which were withdrawn. So you now begin to see a bigger economic game which also uses science as a way of legitimizing and validating the things which they want to give out to you. Of course, using data, science, all that and so on in a way that very difficult to discern. Let me give you two more such examples. One is buildings. Now, when people say that this building is scientifically designed, first question one should ask is, what is the expected life? Nobody tells you that most buildings are designed for 100 years. But civilization time scale is much longer than that. If a building is designed for 100 years, it is very likely to begin falling apart in about 50, 60 years. Within that, the rational design will work. Same thing is true of bridges. Same thing is true of even storing nuclear waste scientifically. People say, oh, this is safe for next 500 years. But then what after next 500 years? So the question is that to the parameters within which the scientific method is many times applied to give you the best possible solution, the boundaries of it are not really shown to you, and you are not really in a way you are discouraged from looking at those boundaries and beginning to believe what is given to you. So therefore many things come as scientific may not really be scientific in the sense of a final word on things and so on. So one has to be careful. I mean, there is another kind of legitimacy, as somebody was mentioning, that even people say that astrology is a science, because science, somehow it has happened that if technologies want to gain legitimacy from science, even practices which are completely different from science also want to gain legitimacy from science. People do say that, everything in Vedas is scientific and all that and so on, because I think people know that science has become something which has a much larger appeal, and therefore it is also kind of akin to a misinterpretation. That was the second point I wanted to make. The third point is about what is taught and how it is taught, about the pedagogy of, in general, I would say. And I think one has to step back and see, first question one should ask is that who should design the curriculum? Who should decide what should be taught? Now that's a complex question. Of course, one is the state player. See, a very simple contradiction which is appearing today, and we are kind of worried about it, is that X is being removed from the curriculum. As I think later panelists will talk about, that Darwinian evolution is being removed from the school curriculum. Another, of course, is that history is the most favorite topic from where people remove things and add things, and this has been going on forever. So one possible viewpoint one can take is that the state or the funding agencies, companies who are selling products, these are not the agencies which should tell you what is to be taught. Then, of course, second layer would come is that then experts should tell you what should be taught. Historians should decide how history should be taught. Scientists should decide how science should be taught, all that and so on. But that also leads to very interesting kind of problems, because different groups have different power to influence pedagogy. They may be academic groups. So let me give you an example which I have been engaging with for a while. In the matriculation exam all over the country, geometry and algebra is considered essential. If you want to do 10th, you must know a certain amount of geometry and certain amount of algebra. I have nothing against it. I'm a theoretical physicist who use these things all the time. But being able to identify musical notes properly and making sense of music has been considered unessential. It's a vocational subject. If you are interested, you learn. If you're not interested, you don't learn. Now, who decided this? Now, of course, if you ask physicists to design physics syllabus, they will give you a way to do it. If you ask mathematicians, they will give you certain quantity of mathematics. But who will decide how these different packages or the packets have to be put together, and what is important and what is unimportant? If you actually look at the data from practitioners in various fields, and I did this survey on doctors, because doctors do science, they move into biology, but they all have learned geometry and algebra in their matriculation to a fairly sophisticated level. I mean, if you look at the 60 theorems in the 10th class geometry, it's a fairly sophisticated Euclidean geometry which is taught. So one surgeon told me, since a surgeon sitting right on that corner, he told me, had I been told music while doing surgery, I could play some of the good notes in my mind. So maybe as a surgeon, learning a little bit more formal training with identification with musical notes would have been made that person more richer and would have helped much more than those 60 theorems of geometry. I'm not saying remove that and put that. I'm making a point here. Then it comes even one step further, that what exactly is the literacy? So if you can read and write, you're literate. But if you don't understand music, doesn't matter. You're not called illiterate if you don't know how to do this. You cannot make a joint and make a chair from wood. You are not illiterate. You are an illiterate carpenter maybe, but not an illiterate person. So this whole emphasis on reading and writing and learning some basic mathematics being the two main ingredients of literacy, I think itself is questionable. So having said that, I think one has to then move much more backward, take many steps back, and then look at scientific method, look at issues in pedagogy, issues in curriculum, all that and so on, and then think afresh. Of course, once you lay all these things on the table, still it's very clear that out-of-state players and people who control things and the people who are experts in their disciplines, temporal choice should be the experts in the disciplines who should decide what should be taught. And one should not hesitate to take a very clear stand that if biologists think that evolutionary biology should be taught to school children, and if historians think that history has to be taught in a certain way, that should take weightage over what policymakers and the governments and states think. But even this needs to be rethought, and a much deeper debate about how all this should kind of unfold. Well, these were the basic points I wanted to make. I want to make two more points, and one is that this whole idea of, after all, what comes first? I think science is a human take on the world. So even rationality or logic is a human invention. So sometimes I feel that when I talk to my friends who are very passionate about disseminating scientific method to larger public, begin to put in as if this is a gospel truth, as if the flow of rationality and logic has come from an external source, and then it tends to look self-contradictory. So I think that also is a circularity we should avoid. And the direct connection with the world is another method to look at the world. So direct connection is direct connection. You want to understand a dog, one way of course is that you understand what species it is, this, that, evolution of dogs. But a direct connection is that it's a dog comes to you pet the dog, you look at the dog and you build a connection. So this aspect also I think is extremely important. You can do that with a stone also. You can do that with flowing water also. So I think the scientific method giving you certain insights about the world is extremely important, because it's at a given time the best possible predictive model mostly, as we call it, and give you an understanding and insight. But there are other insights about the world which humans are capable of, and which come from different ways of engaging with the world, and those also should not be undermined. But in this whole debate, the first order things should be definitely recognized, and I would like to clearly state here that one should prefer experts from subjects to decide over matters, and one should definitely interrogate any predictive models from the point of view of statistical validity, as the previous speaker was talking about. Thank you.